Well, good morning, everyone, and welcome to Great Data Minds War Wounds and Wins Machine Learning Stories from the Front Line. Today, I am surrounded by three of our favorite advisors, Sharon Alpress, Kevin Hill, Anthony Rodez, and behind me and supporting us all are the women behind Great Data Minds, Alexis and Julie. Thank you both for helping us out here today. So, Anthony Rodez, he's the lead data scientist at Panasonic on the smart mobility Cirrus team. Um, they do data science on the connected vehicle technology. And the team's mission is to reduce roadway congestion, carbon emissions, and roadway fatalities through data scientists, through data science. What a great purpose there, huh? And also joining us is Sharon Alpress. She's part of DCP Ventures Group and is focused on scouting the startup ecosystems for partners to co-develop transformational digital solutions across the IIoT machine learning value chain for the natural gas midstream sector. Sharon's got a master's in some of the early applications of computer vision machine learning for remote sensing use cases. This is brilliant. That's like, I feel the sparks just flying. And then also joining us is Kevin Hill, who received his PhD in cognitive neuroscience from University of California, Davis. He spent a decade helping companies in all sizes to be more data driven. Kevin's currently the owner of Human Powered Technology and helps health tech companies understand and optimize how people use digital therapeutics. And I would just want to share with welcome, guys. I am so excited. And guys is a generic term that I use because I'm a Chicagoan. Welcome and thank you for joining us. Um, uh, Something I just want to share with our audience. Our focus this year is making sure that we do everything we can to help companies really start to double down and leveraging machine learning to differentiate and optimize the performance of their organizations, no matter what sector you're in. And um, wherever we can help, please feel free to reach out to any of us, the three advisors on the phone, or Julie or myself. All right, so let's get started. I'm really excited about this discussion panel. So I'm going to just fire out the first question and let's let the dialogue happen. So what are some of the key critical contributions to a path towards a win with machine learning? Anthony, what's your thoughts?
Yeah, I would say, from a data science standpoint, one of the things that I've realized is that it's really critical to have the data engineering help. In being able to develop a data science environment, you really have to have a strong data pipelines. You need to have that data engineering help to clean the data, manage the data, and get it into the proper locations so that you can, start that data science process, machine learning process as well. And so I feel like one of the big critical things is really that data engineering side. Now, a lot of times, if you're a data scientist without a data engineering team, you're gonna be playing both roles. You're gonna be cleaning the data, processing that data, as well as getting it ready to feed into your machine learning model.
Mhm.
Nevertheless, even with a data engineering team, there's still a lot to do as a data scientist. You're still having to deal with missing data, and how do you deal with that? Do you remove that data? Do you impute that missing data? So there's still a lot of data processing and cleanup to do on the data science side, let alone just getting the data landed in the proper location
Mhm.
for that development work.
That's interesting. Yeah, but I spent years building up my data warehouse, and I still have to do all this data engineering stuff. Sharon, I mean, what's the deal there? You know?
Well, I think data is a journey, right? It's never done. Um, and I like to look at it really from to think about what the business value and the problem is you're trying to solve, and take that
Mhm.
in a really incremental, small approach, right? So
Mm.
instead of trying to build out an entire data strategy and to kind of build up your entire data warehouse. Let's just look at that one small problem that you want to solve. Look at it from a business perspective, and always keep that in mind as you're going through, all of the execution details that Anthony talked about. And then you can iterate really fast and learn and figure out, are we on the right path? And you probably will uncover additional data that would be helpful in developing the model that you can then go out and get, right? And so you allow that process and that journey to inform what data or information you need to collect, you need to go and purchase, you need to mine, you need to engineer, from all different kind of sources for your model.
That's interesting. It sounds like a lot of continuous decisioning happening. Do I pivot away from our current hypothesis, or do I persevere? Am I onto something? Yeah.
Yeah.
And you hit on the value thing. I love that. It's like, let's find the big pile of money, but let's do it incrementally to get there. Because I read a lot of research publications, in particular from McKinsey lately. They've been publishing some great stuff, and they talked about the fact that there's an incredible amount of latent value waiting for us if we could leverage some machine learning capabilities to optimize ourselves. But there's also risks / consequences that can come along if we're not careful. What will inflict the deepest wounds, Kevin?
Yeah, one thing I like to say is that everyone wants to be data driven, but very few people want to let the data drive. And I think that's sort of the flip side of what Sharon was just outlining so well, that data science journey. And during that sort of iterative process, you end up coming up with a lot of information and critical business information that may impact whole business units, and it may really sort of need to be integrated with overall corporate strategy. And that can be a tough and painful discussion and process. You really have to get down at, quantifying some of these business values and sort of understanding, for example, what's the different costs and benefits associated with a true positive versus a false positive or a false negative. And those can be difficult decisions, especially if the people who have to make those judgments haven't been exposed to data science in the first place.
Yeah. Any other kind of wounds or
Yeah, I mean,
risks that we got to run into there?
Yeah, I certainly think that those are very similar to the types of questions that a data ethicist might ask, right? Of what are the real trade-offs that we have to consider? What are the costs? What are the bigger questions that we're about to hit us around the next corner? So often people think of the ethics of data science as sort of a pretty restricted subset of questions, but I find that similar types of discussions end up happening a lot when we think about data science strategically.
Yeah, I've been hearing a lot of rhetoric around ethics lately. Anthony, any of the other kind of concerns, things that we need to be watching out for?
Yeah, one of the challenges we had working on a large scale model is the cost to develop the model. So we had billions of rows of data, and one of the challenges was if we were to run that entire data set, we'd be spending thousands of dollars to run all that data through the model and develop that model. So there's a trade-off there, just like Kevin was saying. Do you take and spend all that money and create the model based off all the data, or do you take samples of the data? And when you're doing that, you have to be careful about the bias that you could potentially put into your model. When you take these samples. So there's definitely a trade-off in understanding the cost benefit analysis there of how much data you're gonna use to train your model, and also being aware of any type of bias that you can potentially put in to your model as well. And I think that gets kind of back to the ethics side of things. In the connected vehicle space that I'm in, we're not necessarily concerned with that as much as we're anonymized vehicles, versus if you're in with a social media area, you're going to have potential for bias and other ethics, issues there.
Mm. So Sharon, in midstream processing, you guys are using machine learning to what, monitor the critical assets, or what are the risks around that? Some of that.
Um, well, I mean, it depends how you look at it. One of the risks with machine learning is that it's not foolproof,
Mm,
right? And every model is going to error in, either false positives or false negatives on that model. And then you need to think about what we think about a lot is, what are the impacts to operations if it does predict incorrectly?
mm,
And so we're always thinking about that from the midstream perspective, because we are continuous operations. Um, in the midstream, and so we're looking at predictive maintenance, condition-based maintenance of our assets. One of the things that we are also looking at is, when we build these models, let's get them into the hands of the users. So the users, the amount of feedback and information that we get from the users because then we say, okay, what decision would you make from this predictive, risk score that we're giving you, on the likelihood that this particular asset will fail in the next week or 2 weeks.
mm-hmm,
And because there's a user cost to go out and um, inspect the asset, right? They have to
mm-hmm,
drive there. There's a loss of some other work that they may be doing. And so one of the things that we really want to get building the models is great. Having an accurate model is great, but then how are we going to use it? How is it going to drive the needle to really improve the operations? So we have more uptime. We have, a higher reliability of all of our assets.
mm,
So we're really thinking about it. And I go back to like what I talked about earlier, is that we really think about it from a business perspective. Well, I do in particular, right? There's the building the model, but then how are we using it and how are we rolling it out, across the organization?
mm-hmm. Again, when I, do research on, some of the barriers to entry on being successful with machine learning, I'm hearing that there's this quote great divide. The majority of these machine learning solutions that have great promise don't get operationalized, don't get adopted. How do we overcome that, Sharon? I'm still on you. Sorry. Or anyone.
um, I mean, from my perspective, it's really thinking about it like a product, right? The machine learning piece is it's just a model. You kind of equate it to an equation or a mathematical equation, right? So you can write the equation. It's, obviously more complex, but at the end of the day, what are you going to do with that? What decisions are you making? How is that affecting, the organization? And I would say, if you want to dive into machine learning straight away as an organization, that's probably not the path you want to take. First, taking that journey and getting into analytics, and just understanding your data. And that's what we've done. And we've spent 2 or 3 years just doing some basic, analytics, thresholding, alerts, alarming, and then we've taken action on those. And that's really informed us to say, okay, well, now as we start seeing how we can continually move the needle into improve our process, can machine learning, so it's a hypothesis that we have, we don't know, can machine learning continue to close that gap over what analytics can just provide us?
Mm-hmm.
Yeah.
Any thoughts there, Kev?
Yeah, I mean, I think that focus on the process, I think, is so important. One sort of concrete example there that I can add to that is that aspect of data cleaning that I think Anthony alluded to earlier.
Mm-hmm. Mm-hmm.
It's one thing if your data scientist knows how to clean the data and what's good data and what's bad data and what data to throw into a model. But when you think about the end-to-end machine learning lifecycle of operationalizing that,
Mm-hmm.
you need now have an automated system that can clean that data and organize that data for you every single day, right? And that's a much bigger project all in of itself. And I find that a lot where when I come to help companies, they want to do machine learning today. Sometimes that can work, and sometimes it's a step back and said, okay, great, but we need to really start centralizing your data, all the classic sort of data warehouse discussions about a single source of truth and all that type of stuff as well. There's a good side and bad side of that, right? One is that that can be frustrating. People want to get to the great, interesting AI model today, and that's understandable. But the good side of that is all of those investments that smart companies were making over the last decade in understanding analytics, data warehousing, and all that translates very well into the machine learning space as well.
Yeah. So what do we do? How do we effectively monitor and alert when things are drifting, whether
I can
it's the data itself or the outcomes of the model itself?
I can take that one, Mike. So that's kind of the side of ML ops, machine learning operations. It's very similar to DevOps in some regard. You're looking at how do you maintain your models over time, analyzing drift, making sure that your model continues to provide that value and that output. So I think that's a really important piece that I think people overlook sometimes. They're so focused on getting the model developed, they don't think about, okay, how do we put this into production, maintain it in production over time, and continue to monitor that model. At what point do we need to retrain that model and put it back into production? So there's other processes that need to be also thought about to maintain the value of your model over time. And that's a whole nother kind of area considered as ML ops.
Hmm. And is it fair to say, I'm just going to throw this out. I'm putting together these machine learning engines because I'm trying to affect behavior, right? I'm trying to affect some kind of outcome through a prediction of likelihood of something, right? At some point, that behavior has been affected. So, is there a difference between targeted drift and unexpected or undesired drift? And how do I account for that? When I think about the life cycle of machine learning, it's not
Yeah,
just, yeah.
yeah. No,
Go
I
ahead.
mean, I think you're totally right. There is that difference that in these complex environments, as soon as you're affecting the environment, you expect the data that comes from that environment to change.
Hmm.
Um, it can be very hard to determine where your change is coming from, though, and that's I think part of this human in the loop aspect of data science and machine learning that's so important, that you have people who either one person who both knows the data and sort of is a subject matter expert and can understand what these trends and changes mean, or just really good operationalized
I
processes that
love that
allow.
word.
Yeah, I know, I've done it twice now. But these processes that allow those two groups to integrate really closely together.
Hmm.
If your data science team is just stuck in an IT department and never talks to anyone outside of IT, you're probably going to have a painful process there, because you're not getting the data experts really close to the subject matter experts who will understand really what those trends, drifts, shifts, anomalies mean.
Hmm. Hmm. So I'm loving the focus that you guys are helping us understand around the human connection part of this thing, right? So we talked about, let's get to the business value prop. Let's make sure we got the right entitlement to the right kind of data to solve the problem. And if not, is there a way that we can avoid bias by conditioning that data properly? Um, this is some complex stuff. So Sharon, does technology matter or not here? And what should I look out for?
Oh, Mike, I could talk the whole hour about this. Um, again, technology shouldn't lead your machine learning project or decisions. Your goals should lead what you choose to do with machine learning technology, right? There's the landscape today is so broad, right? So you could develop your model, just using the like a TensorFlow library for example, and build your model and your DevOps pipeline all from scratch, right? And the beauty of that is that you own everything, right? You own the IP, you own that whole end-to-end process. Then there's what I call like accelerators, right? Industry-specific accelerators, where there's a model that's already been built. Like say, for example, in the midstream industry around compressions, like say someone builds a model and then has 5 or 6 customers and has used all of that, compression machine data to train that model. Then as an organization, you can leverage a lot of learning and fine tuning of that model that's already been done before, right? So you don't have this long journey of cleaning your data. Well, you still have to clean it, but do the data engineering, figuring out which features, are the most impactful into the model. So it really helps you accelerate. But the thing there is that you don't own that. Typically, you don't own that model, right? So you can't then take it with you. If it's so there's a big gamut there. And then there's the auto ML space, right? Which is really, really interesting. And I love the auto ML world because I call it democratizing machine learning, right? And it's never going to replace the data scientists, but I think it brings that's what Kevin was talking about, the subject matter experts that understand the subject, understand the data. It gets them closer to being able to play with the data, the models, kind of get the output, see, kind of have the machine auto select which would be the best model given the data that they're putting in and the parameters and what they're trying to solve for. And I kind of see that as kind of a leading path into like the data scientist, right? So then once you have that kind of set up and run, then I would suggest you then hand that off to the data scientist just to validate, that everything is like we're not breaking any rules or kind of doing anything that we shouldn't be doing, but it really helps you accelerate kind of and allows your subject matter experts to step into the world of a data scientist without having a PhD in data science. So there's real, and then in between all of those, there's all these other different offerings of ways to do machine learning that's out there. And so, I would say you really have to think about, what are your goals as an organization, and maybe map out your roadmap to machine learning like over 5 years. Maybe our first year, we're going to use these, out of the box pre-trained models, and we're just going to learn a bunch of stuff and start using it. And then over time, as we start building up our core competency, we'll then start evolving into maybe, auto ML or, writing our own models with, the root libraries. So I think there's a lot of variability. There's a lot of options out there. And I would just say, don't lead with technology, lead with your business case and your roadmap of where you want to go with machine learning.
And I'm seeing a lot of SaaS kind of offerings, almost like full platform services capabilities. Anthony, in the connected vehicle space, have you had any experience using some SaaS models or full platform models?
Yeah, I mean, we look at we have a huge landscape of different tools that we can use. One of the things that we usually start off with is a small data set, working locally on a laptop using like a Jupyter notebook, and that kind of gets us started so we can kind of understand the data, profile the data, do some data exploration. When we start getting into scaling the data and being able to put it into a production environment, then we're looking to move into like an AWS environment using a SageMaker model, something like that, at a larger scale. So, for us, it's a matter of, using the open source tools. There's quite a few out there right now to start off with, and then looking at what does your environment look like. And a lot of times, companies have, a GCP, they have Azure or AWS as kind of their overall, environment they're going to be using for these models. So then you'll move your data set into that environment, or if it's already there, you'll start developing your models into that environment.
There's so much technology out there, though. I mean, Kevin, how do you keep track of all this? How do you determine?
Yeah. Yeah, definitely. I mean, this is a question that comes up almost every engagement that I do, right? How are we going to get this done? And what I found most effective is to focus on that last mile first, which is really how are you going to, give data to this system, whether you build it in-house, whether it's a cloud provider, whether it's a platform, and then how are you going to get the results out of that and actually have it impact some relevant business decision? Right? I mean, it's got to do something in the real world. It can't just sort of stay inside that platform. And thinking through that process, that's really what tells you how much you're going to have to change your own internal systems anyways, and how much you can sort of outsource or put that onto a platform. And every company's going to have a different answer there, right? Because they're going to have different levels of sophistication of their data pipelines that they already have internally. Microservice architectures work really well with this, right? Because you've got sort of a clean line where some AI or ML system can just send a request to some endpoint. So there are definitely, red flags and green flags there for how much do you want to build internally and how much can you outsource.
You guys, Sharon, you hit on it a little bit earlier, and Kevin, you just kind of poked on it again. What about concerns around giving up intellectual property? Where I might be using a predefined, prescribed machine learning model itself, whether it's a neural network or some, I don't know all the details around some of these things.
Yep.
But depending on how I'm building this or what enabling technology I'm using, is there a concern around losing or retaining machine intellectual property, Sharon?
Well, I think it depends how you set up your models and your partnership with a particular vendor, if you're going to use a vendor versus build it all in-house. I think it is a consideration. I don't think it's like you that you will lose, IP, but I think it's a consideration that you really have to think about at the outset. And if you wanted to say switch platforms, switch vendors, what does that path look like? And understanding that ahead of time, I think is really critical.
So if I've got this, go ahead, Kevin.
Yeah, sure. I mean, there are lawyers that specialize in exactly this, right? So I mean, definitely, we're not offering legal advice.
Yeah.
But
machine learning lawyers.
Oh, absolutely. They're whole firms that is their specialty, right? They specialize in how to protect your IP around algorithms and data. So I'll having worked with some of them, I'll try to give a non-expert's summarization. Often it's very hard to patent or protect the core algorithm because you're using essentially research products from 5 years ago, right? Some very smart people in some universities have come up with the core optimization or learning algorithm, and that's public domain. But again, when we've talked a lot here about the business value, the business process, the business purpose of all of that then now falls under traditional IP protection. So that's really where you're focusing is how do you use the system, how do you integrate the system, and then there are a handful of companies that are willing to invest millions of dollars into ML research that get to that threshold of blurring that line and maybe doing some real true algorithm development that can be protected. But for most companies looking to just enter in the space, that's not going to be a realistic goal.
Yeah. Sounds like we're heading towards additional focus from a regulatory perspective as well. As machine learning continues to be adopted. I'm wondering with these lawyers if they're just going to help us with their IP or help us stay out of jail. So leveraging algorithms that have been built as a result of academia or some kind of research body, thought body, body of knowledge and whatnot. as these algorithms get codified and they get purposed, like there's targeted business problems that different kinds of models can solve. That sounds like it's starting to open the door towards the citizen data scientist. Sharon, you kind of poked on that a little bit before. Is there a concern around this? Democratizing machine learning, Anthony?
I think there's two sides to that. I think one side, it gives a lot of subject matter experts the ability to start getting into the data a little bit more at depth. Looking at the data from a model perspective and understanding what the potential is with the data. A lot of times these SMEs, they already have kind of insights of what the data looks like, the trends, and they already have an initial idea. A lot of times, I think these tools give them the ability to see how can we leverage this insight that they already have and put it into a model. So I think that's beneficial. On the other side, though, a lot of times these subject matter experts don't really understand the model from a data science perspective of what the results actually mean, how to evaluate the results, or how to maintain these models in an environment for a long term. So that's where the data scientist kind of comes in and helps manage that process and make sure that the outcome of what they're looking to have is truly what it is, and to help with the kind of the end point or the end process there.
Is there some prescribed methods around doing these kinds of reviews? Bringing a subject matter expert that understands the business and a data scientist that understands the black box or the opaque blocks. Sharon, have you subscribed to certain kind of methods to do this check and balance? I want to enable this analytics at scale, but I have to be careful, I'm thinking.
Mm. Yeah, so how we enable it, we're working on a machine learning problem right now in our, predictive maintenance space that I mentioned. And for myself, having a product management background, we really run this like a product management approach, right? So we follow, agile. We have the stand-ups. We have, weekly kind of sprint reviews. In a sense, they're kind of like model outcome, looking at accuracy, looking at recall, looking at precision of the model and development, deciding whether or not we need to build a new version of the model. And the way we kind of bridge that together is that we have the subject matter experts and the data scientists in all these meetings together, right? Where we combine the teams. So sometimes it's hard because we're speaking very different languages, but I think it's really important to start bridging that knowledge, right? So the data scientists start understanding the business, and the business starts understanding the data science machine learning language. Like, what do we mean by precision? What do we mean by recall, right? And when they start to understand that, the business side, then light bulbs go off and they go, oh, well, what if we were to bring this other piece of data in? How would that feature, help drive the accuracy of the model? And so, and that's how we approach it. I'm sure there's lots of other ways of doing it, but that's how we do it internally right now.
Hey, Kevin, as you're out with your clients, I love that, Sharon, by the way, that they're truly forming an agile team that has the business expertise in there along with the technical expertise. Kevin, you do a lot of work with varying organizations. What have you seen be most effective?
Yeah, and I think Sharon hit a lot of it right on the nose there. And I love that sort of matrix team approach that you have SMEs working day to day, doing stand-ups with the data scientists as well. One way I sort of often frame this is that the SMEs have these complex models already running in their heads, right? They're understanding a whole bunch of different data sources and making very complex decisions on a day-to-day basis. And the data science team's job is to get the model out of the head and into an automated system. And that helps sort of frame a lot of the discussions we have about, why are you making this decision, or why are you looking at the data in this way? Usually there's a good reason. And that can be a little hard to fit into a traditional sort of agile process. it's a much more exploratory, research oriented approach, especially at the beginning, right? It's hard to say, oh, in exactly 2 weeks, I will have exactly this much value out of this interaction between the subject matter expert and my data scientist. And so it's for a lot of the companies I've worked with, the key has been knowing when to transition between those two states, knowing when to say, all right, we're sort of researching, what the data scientists would call exploratory data analysis. Okay, we found something here. Now let's go and operationalize it, right? Let's not just go explore more. Let's not just go dig in and make our model perfect. How do we, use an agile process from that point on to really start having an impact upon the business? And so then that's going to help build these feedback loops, right? That's what allows us to be iterative in our whole process.
It's interesting, because we're pushing pretty hard. Sorry, Anthony. We're pushing pretty hard on helping companies understand, helping our customers understand that taking a lean agile approach is the way to go for the analytics value stream. But does data science fit into that mindset? Where I'm building little analytic products and I'm doing it quickly and iteratively. Does it work in data science, Anthony?
Yeah, so I was gonna kind of go off of what Kevin was talking about here. In our team, we've kind of been on both sides. We've continued to do agile, but sometimes we initially started off where we're doing sprints, just like the engineers were doing, and we found that it was pretty difficult to keep the work into those 2 to 3 week sprints. So we ended up going over to a Kanban type of process. What you find is when you're doing data science, let's say you get a data set that has 50 columns on there. As you're looking through those, you start analyzing this data and you realize, okay, there's correlations between these features. How are you going to handle this? And it becomes more of a research problem in a sense, and it's not like a definitive timeline of like, okay, I'm going to be done in this amount of time, and sometimes that spills over. So for us, we ended up using more of the Kanban type of process. If you have a model that's already in place and you're looking to do specific things, that becomes more engineering-like, and you can work on things. You can set up a timeline to do that type of work. But when you're kind of exploring the data and understanding how, what the best way is to work with this data, sometimes you need a little bit more flexibility than just a regular sprint.
Are we running the risk of getting caught in exploration cycle? How do we break out of that?
Yeah. Sorry, I'll jump in. But yeah, I mean, I think one thing I really like to do is, even if you're in a research mode, still having artifacts and deadlines involved. It can be as simple as sort of a PowerPoint presentation on a couple of graphs of the stuff that was interesting in your data, right? Or interactive Jupyter notebook with some code embedded in it, right? And just having, even if it isn't the final answer, but we say, it's a concrete thing, an artifact that you guys can discuss and make a decision, right? Is it worth exploring more here? Or do we have enough that we can go and start to, really roll it out and go and take an engineering mindset on? Just even those little small check-ins can help the team be more focused and more active in asking themselves that question. And then also the stuff that Sharon was alluding to earlier of having a subject matter expert integrated into the team, like, they'll raise their hand and be like, yes, I want that now, right? That can help a lot with that decision.
Sharon, it looked like the question resonated with you. Do you have some additional thoughts?
Yeah, I mean, we pretty much follow exactly what Kevin mentioned. We may not have like a usable feature or product to go and demo, but what we do have is, just a checkpoint of like, even if it's just graphs and trends, this is what the model's showing, or this is what it's predicted thus far. Then we bring in the subject matter experts and say, just give a reality check on it. So as we're marching down that, the machine learning tasks, all the way from, feature identification, EDA, all the way through, that we're marching in lockstep with the objectives, right? And we're not diverging. So having those check-ins, I think, yeah, even if they're, sometimes we just have PowerPoint slides, or we look at kind of a percent accuracy as we're kind of testing the model. I think that just kind of gets everybody at the table around, around the current status of what that hypothesis test and exploratory analysis that we're doing, right? So everybody can provide the input. And so we just make sure, I think of it like this big glowing ball that we're kind of moving down, this road all together. And we just make sure that it's kind of going down the right path. And,
the orb.
The orb, yeah. This magic black orb, the black box orb. Yeah, and it's just those, I think it's those check-ins, and that's just so critical along the way.
Gosh, guys, how are you bringing the business along? How are you educating your business that this is what this stuff is before we can even start to tell them it's important that we get on this bandwagon? It's a lot of complexity here. Give us some techniques or tips on how we bring our business along. It feels a little bit daunting. Anyone?
Yeah, I could give it a shot. I mean, we've been down, like, I think, again, it's a journey, right? It's starting off with the analytics and the data and kind of having people use that. And then there's like just a level of curiosity. Machine learning, AI, like, you can't be working in 2021 and not have heard of AI and ML, right? And
right.
So I think it's, for us, there's just this understanding that this is where we need to go to. And so when we start looking at transformational projects and technology, and how can in the transformations, how can we transform our business? We're always asking, like, can machine learning, help us get there? And again, it's a hypothesis test, right? But I think at least kind of having that kind of an understanding of how machine learning is different from just a set of analytics that's going to cross a threshold, determining whether or not, I'm going to alarm after crossing a threshold. And it's a lot more than that. And I think for us, part of it has been the business has been using the analytics and consuming the analytics, and they're starting to see the limitations, right? They're starting to see the limitations of how, like, we've accelerated so much in our operations, but now we've kind of hit a little bit of a plateau. And can machine learning move it forward? On the other side of it, which is something that I've been really thinking about, and kind of I've started to kind of put this out there in the business, is those teams, those subject matter teams who are part of these projects. How can we get some sort of training for them which isn't too technically overwhelming, right? And I think that's actually a gap, in our industry. So I've kind of looked at the landscape, and I look at some of the trainings that's out there. You look at like Coursera and what's out, and some of them go so deep technically. And I'm like, this is just doesn't fit our, what they need to understand, but they still need to. I call it like a machine learning strategist. Like, you've got to understand, if you're going to go down this path, you've got to understand that. And so I've kind of started to build kind of my own set of training resources for the business to try and live in between the two.
Yeah, because if I was a business owner, I get it. I have to get on board because I'm going to be left behind. All the research firms are telling me that, so I must do it because my peers are doing it. But I don't know what it is. What am I getting into? How do we help our customers, or being the people in the business units we support, or as a consultant, customers? How do we educate them on what they're about to step up to?
Yeah, I mean, I think it is often a little bit more of a daunting process than people want it to be. A little bit more of a holistic process than people want it to be. I think everyone understands and has sort of accepted the potential of AI and ML. And so it's really just about the nitty gritty details of actually getting it really running inside your business.
Mm-hmm.
And one thing I think that helps there is to really focus on the errors and the mistakes that these systems make. There's sort of two things that'll sort of be highlighted when you do that. Sometimes it can be a little uncomfortable, right? No group likes to focus on their failures. But if you have a good relationship with your leadership team, it's certainly possible. And you'll start to see that both, it'll highlight what is the consequence of a mistake, right? What other sort of business processes or systems we need in place to manage and mitigate the downsides of those mistakes, which really gets at how the machine learning group is integrated into the rest of the company. And then also, why is it making this mistake? What data does it need to make a better decision? And where is that data inside our organization? What are the barriers in getting that data from point A to point B, right? Or maybe you as a business aren't even collecting that data at all, but that becomes a whole new sort of project for the company to go and find the right data source to solve this problem. It could be a new sensor. You might use third-party data brokerage services, or just better instrumentation and measurement inside your company. So I think once people start opening that door just a little bit, leadership has a much easier time in understanding both, that we're not wizards and that we don't wave a magic wand and just have money and algorithms come out the other side, as well as, really what it's going to look like to fully integrate machine learning with some business unit or business process.
Cool.
Mike, I was going to jump in and give you a perspective from Panasonic. The ones that are really driving a lot of this data science stuff are the product owners, and they don't necessarily have the understanding of data science per se, but they know what they're looking to build. And so we're building a Cirrus platform that integrates various items like curve speed warning or other items that are important to roadway operators. And so from that, the way it's driven is understanding when the researchers do their research, they reach out to roadway operators, they understand what's the business critical needs that they have. And then that gets pushed back to the product owners. And then the product owners, will come to the data science team and ask us, well, how can we use this data to identify these particular items that we're looking for? So it's kind of an iterative process here of these various teams working together collaboratively to identify what we need to develop, and then how can data science help us get there. So it's not a matter of the other teams necessarily knowing that data science can actually do it or is able to do it, but it's first coming up with what are we looking to develop, and then working backwards and then bringing that to the data science team. And from there, we analyze the data, we do the exploratory analysis to understand what is the potential here, to see if that's even possible before we start going down that path.
I'm loving that. Very customer-centric focused. Let's get out to the actual customers whose needs we're trying to solve. You guys keep bringing us right back to that. It's like, if we're not going after the business value, we shouldn't be doing this stuff. Right?
Yeah.
All right. So where are we going to be in the next 5 to 10 years? What's this space going to look like? Sharon, I'll start with you. What do you think?
I think we're not going to recognize it. The rate of just, going from, I'll call it, basic machine learning to deep learning, the rate of acceleration of the development of these models and the understanding of how all that works has accelerated so much in the last 3 to 4 years. I mean, it's mind blowing, right? And we're starting to walk down a deep learning project with reinforcement learning, and I think 3 years ago we couldn't even have really started it without a raft of data scientists, PhD data scientists, and now there's so many of these models out there, and so therefore the industry's learning and understanding has grown so quickly that I think AutoML is going to really transform industries, and it's going to transform the machine learning industry. Like AutoML is going to transform its own industry in just the way that it can, automate the development of these models. So I hate to punt on it, but I just don't know. I think it's going to be fascinating to see what the next 5 to 10 years is going to look like. I just think, I think that the takeaway for, if I could share anything, is that just start with something now, right? Start building that foundation within your organization today so that you can be carried along in this journey, right? Because I think it's going to be like a tidal wave. And if you're not starting to build that core foundation today, you're going to find yourself in 5 years just looking back behind you and go, whoa, what just happened to our industry?
I love that. Kevin, what does your crystal orb tell us?
I also think that one of the strengths of data science is that you are comfortable with uncertainty, right? So I love that Sharon wanted to say, we don't really know. I think there are really game-changing potential algorithm changes coming down the pipeline. It's going to be really interesting to see what happens there. I think there is one thing that we can say, though, at least with certainty, which is that you'll have more senior leaders at companies that have had experience with ML and more exposure, whether they came out of a data science group and now they're a VP, or whether they just have run and interacted with multiple of these ML projects in the past. And so that sort of deepening of the knowledge of a lot of these best practices, a lot of these ways of framing the problems and benefits of ML that we've been talking about today, hopefully will become more sort of ubiquitous and spread out across organizations that are succeeding.
I'm wondering, is that a generational thing?
Mike, I was going to say, I'm sorry, go ahead.
Okay, if you want to handle that too. I was partially it's just a history of when you came into the industry and when you got your feet wet, and part of it's just experience, right? Like even regardless of what generation you're part of, you can always learn new things and start new projects at your business. So
Go ahead, Anthony. Thanks, Kevin.
One thing I was going to say is, if you look back, 5-10 years ago, there was no discipline for data science. You had your programs in universities, marketing, finance, accounting, so forth. Now, when you look at universities, they're offering data science degrees now. So if we look at that from that perspective, from an educational perspective, I agree with Kevin. We're going to see people going more in the direction of data science. You're going to have more executives and leadership in that area of data science, because it's adding value to companies, and companies, now that they realize that there's value in this area, they're going to dedicate more resources to that. So I think the trend for data science is only going to increase into the future.
Yeah, accelerated rate is my guess too, right? It's going to just skyrocket. Hey, we got a question. I'll throw this out. Anybody jump in? How do we monitor and manage the AutoML to prevent the types of drifts and errors already being that we've already discussed? How do we monitor and manage AutoML to?
So this is one of the check boxes for the features list for these AutoML platforms that some of them have, some of them don't have. Sometimes they're better, sometimes they're worse. So there's definitely tooling and sort of systems that you can put in place that will help with this. But at the end of the day, it still relies on someone paying attention to those dashboards, those alerts saying, hey, this is drifting, and then making a decision on whether that's worth investigating more or whether that's something that's just incidental, right? And so you really still need that human element of who's going to make the decision to have my whole data science team look into this drift problem for the next 2 weeks.
So are we supposed to be as part of our design of any of these solutions, are we supposed to be intentionally building in monitoring?
Yeah, I mean,
And are
again,
companies
like,
doing that?
well, I'll go back to my earlier quote. Everyone wants to be data driven, and no one wants to let the data drive, right? They think, oh, we have a dashboard, great. Now we're data driven. No, you actually have to look at it. You actually have to, make a decision based upon that dashboard. I mean, it's a sad fact of, I think, probably everyone in data science career, that you made a dashboard that you were really proud of, and then you go and look at the usage stats 3 months later and find that, like, it's been looked at once. So I think that that uncomfortable process, has to be sort of more holistic to the company of, do they care about the data in the first place?
How about Sharon, when you guys are building your models, how intentional is the ongoing monitoring and efficacy tracking?
Yeah. So I think it's really important to emphasize that a model is never done, right? You don't build a model and then put it into production and move on to the next product, right? Because a model, so your machine learning model should be continuously learning. And so one of the ways it learns, like for example, in our predictive maintenance, is it learns from a feedback loop where the user is telling the model, yes or no, I'm validating whether or not there is an issue with this particular asset. And so then that validation goes back into the model to learn, and hopefully its predictions get better. But if that human, right, if you have a new, say, a person that's new in the field of identifying whether or not there really is an issue, and they're feeding it in bad information, that model is not going to know that that information is bad, right? So it's really important, I think. Just you've got to monitor it. You've got to continually evaluate it. It's never done. You can't just put it in production and walk away and move to the next one. It's continuous care in those models.
Interesting. Got another question. We got a few more minutes. This might be directed to you, Sharon. Which certifications would you consider for gaining data-driven petroleum engineering, or any societies to get some kind of accreditation from?
Wow. I don't know. Yeah.
Anybody?
Yeah,
it's kind of specific to an industry. That's
exactly. I can't really answer it specific to petroleum, but more generally on sort of data science certifications, I can speak a little bit. Some of them are fine and okay. It's a good, first entry point sometimes to get people comfortable. One of the problems is that there's kind of two approaches, right? You either teach someone how to drive or teach someone how an engine works, right? To understand what a car is. The real like heavy stats stuff, right, really takes, a couple of years to get really comfortable with, and it isn't really well suited to, a 3-day certification process. And then on the sort of how to drive side of things, as we've all talked about, everything's changing so fast that, if you got a certification 2 years ago, you really have to stay active in the field and learning new tools on your own as problems arise to stay current. There's not really any great, you can't just go out for a CE credit every year and get all of the updates about what's happened in data science. It's really, on yourself. But that being said, like if you just want to get started and have a little bit of comfort and interest in it, a lot of the certification programs are good for that.
Great. Awesome. Anthony, any thoughts from?
What I found is, a lot of people, when they're looking to get into data science, the question is like, well, how do I begin? Where do I start? One of the things I propose is starting to learn Python. And the reason I propose Python is because it gives you so many options to work with data. It works with basically all the libraries from scikit-learn, from the data science side, into the neural networks, PyTorch, TensorFlow, and everything. So it gives you it basically gives you the full gamut there. But it also gives you the ability to work with the data from a data engineering standpoint, cleaning data, one-hot encoding, dropping duplicates, those types of things that you have to handle as you're working with data. So that's kind of where I always stand, is say, get started with learning a little bit of Python. That'll get you embedded with the code, because one thing, if you're going to work with data science and data, you have to be able to feel comfortable working with, one of those, the technology as well as the code.
Awesome. Sharon Alpress, Kevin Hill, Anthony Rodes, you guys are amazing. I have so many new brain wrinkles listening to you. You people are brilliant. Thank you so much. And thank you everyone that joined us today. Have a great day.
Bye, everybody.
Bye-bye.
Thanks.
Bye, thanks.